I've been very tired, and I've been very busy, but now I'm back. This last weekend, I attended my local Global Game Jam 2018, and I worked on a few projects and had a lot of fun. And I worked on this project, which is a short little game where you play a rogue signal going from planet to planet trying to find your way across the universe. And there wasn't really anything that fun or gameplay-wise in this game, but I thought that there were a few complex things that we did in order to make it run efficiently, even with a large universe size. So I guess it's not really much of a fun game, but it is kind of technologically cool. We basically made 2D No Man's Sky in a weekend. I wanted to make a very quick video where I discuss a very simple concept. This is where we have an image being rendered in real time and we want to make a lot of these appear on screen all at the same time. As you can see, this image is being dynamically rendered, meaning it's being rendered every single frame. But when I was developing this code on a laptop, it took a lot more of the CPU than it is currently doing right now, so this was running very slowly in this demo. In the program I was trying to make, I knew that planets had to be a certain size and they were going to be fixed at that size, which means I only needed to render each planet once, not every single frame. So in the code for the Game Jam project I made it so that every single time a planet was created and then rendered for the first time, it would create a rendered version of the image that it is represented by and keep it within its object container. Here's the code right here. You can see that this planet is being drawn in this function right here, based on a location, a size, and a glow value. I can increase the glow value by going here, and you can see that the glowing effect is a lot wider now. I wanted this code to be portable so I could tweak it, but still be called from one function and have the image stored inside of the object so that it would only need to be run once in the final code. Now here is the code for the final project itself. There's a lot of extra stuff in it to control a player and to control other parts of the game. When you start up the program, you're presented with a player object that is able to move from planet to planet and float around this universe. And I made the code so that it is efficient enough to have thousands of planets being rendered as soon as they're created and then render on the fly all at once when the program is being run every single frame. This is through dynamic allocation. So in the development of this code that I have generating these planets, the first thing that I do at the very beginning of the program is I create a pgraphics object. This is an image that can be drawn to much the same way that the surface that you draw to throughout the rest of the program is done. Then in the setup function, you need to create a graphics layer and assign it to that pgraphics object. You need to make sure that you do this after the size is set for the program, or else you won't be able to create another graphics object. You need to make sure that you create the actual window that you're going to be rendering the rest of the program to before you create other pgraphics objects. Then here in the code that defines a planet, this class right here, I have a p image called planet image, and this is going to exist for every single planet that exists within this universe. What we have here is a function that is run every single frame for every single planet that draws the planet to the screen. As you can see here, what's actually happening is if the planet image is equal to null, then it will run a function called load image. Otherwise, it will draw the image that isn't null to the screen. Up here you can see the function load image, and what it does is it starts out by initializing the ability to run code on that graphics layer, and then it is drawing the circle itself by drawing these fading concentric rings around each planet. This is the glowing effect. Then it draws the planet itself based on the planet color. You can see before each one of these calls, editable surface dot is being run on this function. That means that the surface itself that's going to be drawing these planets is having this code run on it, not the full main context of the program. Then the editable surface is having its entire contents dumped into this image, and then the end draw is run to finish up the drawing of the planet. Then a new create graphics layer is being built into its place. so that the next time a planet is drawn, it doesn't conflict with what has been drawn to the screen already. So there you have it. Every single planet has its own image assigned to it, and inside of the draw function is where the planets are being drawn. This is a planet system that is running draw planets, and the planet system itself contains every single planet by just going through the list of planets and drawing every single planet using its own planet draw function. Through this process, we can make a very complex universe filled with planets that are randomly generated to the screen. And they look pretty cool too.